Have you ever thought about having an exact copy of yourself? It sounds like a plot straight out of a sci-fi movie, doesn't it? Welcome to the intriguing world of cloning. This concept, once confined to the pages of imaginative fiction, has now become a tangible reality in our present day. The idea of creating an identical copy of an organism has always been a source of fascination and controversy. It's a notion that has pushed the boundaries of what we thought was possible, igniting a sense of wonder in some while sparking ethical debates in others. From the speculative beginnings in science fiction, where clones are often portrayed as eerie doppelgangers or expendable armies, to the groundbreaking realities in modern science, cloning has traveled a long and eventful journey. It's a journey that has led us to question our understanding of life itself. From being a mere figment of imagination, cloning has now found its way into the realms of reality. The journey of cloning began not with humans or even mammals, but with a humble amphibian. In the mid-20th century, scientists made their first strides into the world of genetic replication. In the 1950s, the scientific community was abuzz with the idea of creating an exact genetic duplicate of an organism. This idea moved from speculation to reality when biologists managed to clone a frog using a technique known as nuclear transfer. This method involved removing the nucleus from a frog's egg cell and replacing it with a nucleus from a body cell of a donor frog. The result was a tadpole genetically identical to the donor. These early experiments were groundbreaking, marking the first time humans had manipulated the very building blocks of life. They provided the cornerstone for modern genetic cloning, its principles echoing in the labs of today's geneticists. These initial experiments paved the way for a breakthrough that would change the face of science forever. Cloning isn't just about creating duplicates. It has a crucial role in preserving our world's biodiversity. For instance, consider the Pyrenean ibex, a species we lost to extinction. Through cloning, scientists have been able to bring it back to life, if only for a brief moment. This is a prime example of how cloning can help in conservation efforts, potentially breathing new life into species on the brink of extinction. Here, cloning is more than just science. It's a beacon of hope for our planet's future. In 1996, a sheep named Dolly changed the course of scientific history. Dolly was the first mammal successfully cloned from an adult cell, a feat once deemed impossible. Her birth opened the floodgates, proving that the genetic material in an adult cell could indeed create a new organism. Dolly's existence challenged the limitations of biology, sparking a surge in scientific exploration and ethical dialogues. She was more than just a sheep. Dolly was a symbol of scientific triumph. As we stand at the precipice of scientific innovation, the question remains, what does the future hold for cloning? Advancements are on the horizon, with genetic engineering and CRISPR technology pushing the boundaries of what's possible. Imagine, if you will, a future where we can precisely edit the DNA of any organism, potentially eliminating genetic diseases at their source or creating custom organisms tailor-made to our specifications. But with great power comes great responsibility, and the ethical considerations are immense. We must consider the potential consequences of our actions and ensure that we are using these technologies for the benefit of all, not just the few. Looking beyond the ethical debates, the potential for medical breakthroughs is tantalizing. Cloning technologies could revolutionize organ transplantation, creating perfectly matched organs from a patient's own cells. Imagine a world where organ failure is no longer a death sentence, but a problem we can solve in the lab. As cloning continues to evolve, it challenges us to redefine our understanding of life itself.